Hi, hello, welcome to another lesson of secondary math 2. So today we're going to be talking about symmetry, even and odd functions. Alright, so during this lesson, you will learn how to determine if a function has even or odd symmetry algebraically and graphically. Those are the two things we're going to work on today. Let's get started. Alright, so some vocabulary for us today. We're going to talk about some reflections over the x-axis. Remember, if I have my axes here, my x-axis is the one that goes left and right. My y-axis is the one that goes up and down. Okay, so if I reflect over the x-axis, this means I'm reflecting over that left to right axis, and it's going to be a mirror image. So the y values will change signs, but the x values stay the same. If I reflect over the y-axis, the x values change signs, and the y values stay the same, so I'm reflecting over that up and down axes. Alright, so here's our two new definitions here. If I have even function symmetry, it means a graph that can be reflected over the y-axis and remain the same. If I have odd function symmetry, it means a graph that can be reflected over the x-axis and the y-axis and remain the same. We can also think of that as a 180-degree rotation about the origin. Alright, so even function symmetry. This is a graph that can be reflected over the y-axis, if we remember from the last page. Okay, so we're going to start off with the graph. Okay, so my y-axis is this up and down axis. Okay, notice that goes right through the middle. If we think about this, we have our vertex point right there of my parabola, and we notice my y-axis goes through that vertex point. Okay, if we remember from the first lesson of Unit 1, we call this the axis of symmetry, meaning it's the line that cuts it in half. Okay, that's what I'm looking for. Algebraically, we know that f of x has to equal f of negative x for it to be a function. Okay, so let's look at that. So determine if the function has even symmetry. So I'm looking for f of x to equal f of negative x. Well, we're given f of x right here. Okay, so what we need to do is we need to see if we can take the function of negative x, so f of negative x, and see if it still is going to remain the same. So f of negative x. Remember, anywhere I see an x, I'm now going to replace it with a negative x. So I have 3 times a negative x squared plus 1. And this is where we have to get a little theoretical, I guess, is I'm going to look at this negative x squared part. This is the part I'm concerned about. I'm going to ask myself, when I square something, regardless of what I put in for x, regardless if it's a positive number or a negative number, is that number going to be positive or negative? Well, any two numbers squared will be positive, whether it's a positive 2 times a positive 2, give me a positive 4, or a negative 2 times a negative 2 gives me a positive 4. Regardless of any number that I put in there, it's going to remain positive. So we can simplify this to be 3 times a positive x squared, because I know that's going to be positive. Alright, so we can tell that 3x squared is equal to that 3x squared plus 1. And so we know this has even function symmetry. Woohoo! Okay, we just proved that. Alright, odd function symmetry is a graph that can be reflected over both the x-axis and the y-axis and remain the same. Okay, so let's look at this graph. If I reflect this graph over the x-axis, so we're going to be coming this way, See that point, let's change some colors here. That point becomes that point. It's going to look something like that, right? And then if I take that green point, that green line reflected over the y-axis, so the up and down one, this point's going to move to here, that point's going to move to there, and I now have a copy of my original. So that would show odd function symmetry. Now graphically, or algebraically, I'm looking for f of x to equal a negative f of negative x. Okay, let's see what this looks like. Okay, so f of x equals 1/10 x to the third power. And we need to show that f of x equals negative f of negative x. Okay, so negative f of negative x. Okay, the first thing I'm going to put in here is a negative, and that's showing this negative right here, that negative f. Now we're going to do f of negative x. So anywhere I see an x, I'm going to replace it with a negative x. So I have 1/10 negative x to the third power. Okay, now we can simplify. We're going to start inside the parentheses. Inside the parentheses, so I'm going to start in here, that green line. And within that green line, I need to start with my exponent, so that red one. Okay, so I know I have a negative. And then we're going to do the same thing like we did with the even function. We're going to say, okay, a negative x to the third power. Anytime, no matter what number I put in there, what's it going to be? A positive number or a negative number? So negative x to the third power means some number multiplied by itself 3 times. So we can put like a -2 in there. -2 times -2 times -2. Positive and a positive, or negative and a negative is a positive. Positive and a negative is going to be in this case, -2, 4, it's going to give me a -8. Okay. Now if I put a positive number in there, so if I put -2 in there, say I'd have it. Yep. So whatever I put in there, it's going to stay negative. If I have an odd exponent, it will stay negative. Okay. So let's look at this. So that means I can simplify this to be a negative 1/10 x to the third. We were just able to simplify that. Now I still have to distribute this negative right here. And that gives me 1/10 x to the third, which, ding, 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 gives me back to my original equation. This shows odd function symmetry. Okay, so the big takeaways here is to determine if something has even or odd symmetry. We're going to determine if a function has even symmetry by finding if f of x is equal to f of negative x. And to determine if it has odd function symmetry, we're going to determine if f of x is equal to negative f of negative x. Okay, here's some now you try problems. I want you guys to look at it. Alright, well, I know that this doesn't have a chance to have even symmetry because my exponent is a 1 here. I know it has to be an odd. Well, it has potential for an odd symmetry. So I'm looking at negative f of negative x. Okay, so I have a negative. Remember, that's that first initial negative. 5 to the negative x. Then we get negative of negative 5x. So I'm doing this inside part first. Distribute that negative here, and I get a positive 5x. We're good. Those are the same, so we know it's odd. Okay, next one. Please pause the video, try it on your own. Welcome back. Here we go. Okay, so I see I have a even exponent, so I have potential for even symmetry. So I'm looking at f of negative x here. F of x equals negative x squared minus 7. I get negative x squared is going to be a positive x squared minus 7. Ding, ding, ding. We have the same answer. We just proved even function symmetry. If you have any questions about this, please reach out. Let me know, see what I can help you with. Thank you and have a great day.